right, law of cosines. So yesterday we took a look at how to develop the law of sines, which, by the way, then gives you an easy way to figure out the area of a triangle. It's real simple. 1/2 two of the sides times the sine of the other side's angle. Pretty easy. So 1/2 AB sine C. Nice. Okay. We then looked at the ambiguous case in all those situations. Don't forget this, though, and don't forget this, and don't forget this. If it's not a right triangle, you can't use right triangle trig, and therefore you have to use the law of sines or the law of cosines, right? Non-right triangles. So you got to be careful there. You got to keep those separate in your mind. All right, so again, we're going to use law of cosines to solve oblique triangles of side angle side and side side side. So use law of cosines to solve oblique triangles of side angle side and side side side. Formula is pretty easy, and I start always with Pythagorean theorem. C squared equals A squared plus B squared. We know that that's true. We know it works. The law of cosines is pretty simplistic from there. Well, I shouldn't say pretty simplistic from there. All right, next thing, take your blue and then go -2 in blue. I'm going to take my red and see how it's C squared equals A squared plus B squared. I need the A times the B. So -2AB. Now comes in the law of cosines. And you'll be amazed over the years how when I've asked students to write the law of cosines, how they'll put the sign next. But it's the law of cosines. So therefore, the cosine comes next, all right? And if you look on the right, we have A and B in two different places, and there's no C to be found, and it finishes up with angle C. So C squared equals A squared plus B squared -2AB cosine C. Before I go any farther, by the way, you can use the law of sines and law of cosines on right triangles. You just can't use right triangle trig on non-right triangles. So, and don't box this in, I'm just trying to make you think. So if I were to use the law of sines, or I'm sorry, the law of cosines on a right triangle, and I was going to solve for the hypotenuse, guess what the value of -2AB cosine C would be? Luke? Are you sure? Sure, because it's a Pythagorean theorem. What would be the angle? C is always opposite what angle? A 90-degree angle. What's the cosine of 90 degrees? Do you have the picture in your mind? What's the cosine of 90? If not, punch in your calculator. Hit 90 degrees, hit cosine, and your calculator is going to tell you it is 0. And so the 0 times the AB -2 gives you 0, right? And all that goes away, and hence you're left with Pythagorean theorem. All right, so, again, there's 3 forms of the law of cosines. That's the one I usually say to students, just learn that one, and then you can do all the other ones. But we'll write them in. All right, so the second intonation of it has a B squared. So now you need an A. And you need a C, and I'm trying to save time with my color here. So that's A squared plus C squared. You just follow the pattern. -2, what would come next? -2, then what comes? AC, and then cosine of B. And we can do the exact same thing for A. And I'm just saving time with my color. So there's all the intonations of that. Again, if you just learn one and understand the pattern, then you can do it for all of them. Just learn one, understand the pattern, do it for all. Okay, so let's try it out. First example here, we're looking for side A. If you go to use the law of sines, you're not going to be able to, because you don't know you don't know enough to be able to use the law of sines. Okay? You have A and you have its angle. You need another sine and its angle to use the law of sines, and you don't have it. So you don't have enough information to use the law of sines, but you can use the law of cosines. All right, so go back up here for a second. I'm looking at Windows. I'm looking at this one right here, right? Because we're going to solve for A. Agreed? And do you agree we'd have to take the square root of both sides, right? And so that's exactly what we're going to do. So again, first time here, let's just write it in. It's going to be b squared plus c squared minus 2bc cosine A. And we just got to remember to take the square root. Okay, now it's just a factor of subbing everything in and making sure you can punch it correctly. So again, I'm going to do that while you do it at your desk. You're just subbing in the values, and then you're taking your calculator out, and you're going to punch it in. You got to get everything in the Radican figured out before you take the square root, but your calculator should take care of that. However, you might need a parentheses when you start your Radican. That's my guess with most of the newer calculators. My calculator, I figure out all the value first and then take the square root of it, but then my calculator takes the square root after you have a value. All right, once you're done, see if your answer makes any kind of sense whatsoever. By the way, whenever you're dealing with a triangle, do you remember the geometry theorem that the sum of two sides must always be greater than the third side? Otherwise, you can't have a triangle. No matter what two sides you pick, it's got to add up to be more than the third side. All right, you should have gotten 15.7. Everybody able to punch that out correctly? Again, you got to learn how to punch it into your calculator. You got to make sure that you're able to get the correct answer. So 10 squared plus 14 squared minus 2 times 10 times 14 times cosine 80 degrees. Any questions on that? Law of cosines. Okay, students don't mind that way. They really sometimes can have a little bit of trouble when they're looking for the angle. Okay, so solving for the angle, I left a little bit of the formula left. So go ahead and finish in the formula. Again, if you need to look, but hopefully you're getting the point now already where you know what to do. So if you can already, fill it in. If not, you need to look, then look. And then from here on out, let's stay together on this first example because I need to make a point. Hopefully you agree that that's what we're isolating. Okay. So c squared. C is 17, and it's going to be squared. Stay with me now. Take your red. Do you agree that A is 21? All right. Let's go way back to pre-algebra. When things are both added to and multiplied times the variable, move things added first. How? By adding their opposite. So do you agree I have to add a negative a squared to both sides? I do. But be careful. It's negative parentheses. And what is a 21? Now look, I'm just telling you. If you try to do negative 21 squared, your calculator might think it's negative 21 times negative 21. That's not what this is. This is negative the value of 21 squared. Be careful. Same thing as with the b. b is 5, so it's negative the 5 squared. The negative is not part of the base. The base is positive 5. So that value is a negative 25 right there. Agreed? Okay. We have just moved everything multiplied times the variable. Now what we have is things, or everything added to the variable. Now we have things left that are multiplied, right? And so hopefully then you're going to do your division line, right? And what are you going to stick on the bottom? We're going to stick the negative 2, and then what's the value of A? 21. And what's the value of B? It's 5. And remember, this all equals the cosine of C. So one last thought. I'm going to let you finish that. Negative 2 times 21 times 5. What button do you use to get the angle? It's the negative 1 button. So please understand, and again, for time's sake, it's going to be cosine to the negative 1 of all of that, right? Is what the measure of angle C will be. So you got to take the cosine of the negative 1 of 17 squared minus 21 squared minus 5 squared divided by negative 2. Listen now. If you're going to do multiplication on the bottom, you got to use a parentheses. If not, you divide, divide, divide. So probably most of you, let's add a parentheses, because for most of you, that's going to save you from getting the problem wrong. If you put a parentheses on the bottom, because that's the way you got to punch it. All right, so see if you can punch this in and get a viable angle. Say it if you got it. Yeah, 32.6 degrees. Questions? Let me see your hand if you've gotten 32.6. That's what I thought. Yeah, I think you need that top parentheses. Cosine of the negative 1, it provides the first parentheses. You provide a second. Do 17 squared minus 21 squared minus 5 squared. Close that parentheses. Hit the division button. Do another parentheses. Negative 2 times 21 times 5. Close that parentheses. Close the whole thing. Hit enter. Hopefully it says 32.6. Do we get it now? Listen, guys. If that top parentheses is what's going to get your calculator to work, then why don't you write it when you write what you're doing? You follow? Because you need it, otherwise you're not going to get a right answer. Okay, so again, you just got to know how to punch. Punch, brothers, punch with care. All right, let's do number 2. Solve the triangle. So we're finding all angles and all sides. As always on these situations, you're going to draw a picture first. Picture first. Picture first. So I look at my situation. I always do the angle first. And so I just start with a line, and then I figure out, okay, 110. Bigger than 90. So I'm going about like this. And that's got to be angle C. Now I have an A and a B. I'm going to make the B the 7 here. I'm going to make that one B so that my 11 reaches. And this, whoa, that can't be A. What am I thinking here? That's C. All right, doesn't matter. It's going to reach anyhow. So I got to go 11 here. So just make it a little longer than that one and make it reach. Yeah, it looks good. Beautiful. This is A. This is B. I just leave the tails. It doesn't matter. And you could have put A on the left and B down below. It doesn't matter. But remember, C is opposite angle C. A is opposite angle A. B is opposite angle B. Okay, so if you look, this is classic side angle side. The only way you can solve is with the, well, you could use the law of sines on this, so that's possible. But we're working on the law of cosines. So let's go ahead and see what we can do. Let's go ahead and find angle, let's find side C, all right? So go ahead and find side C. So once you get good, you go right to the square root, right? First side. C is the one you're looking for. So the first two squared are going to be the other two, right? So the 11 squared and the 7 squared. You're not going to forget the minus 2. You're going to do the 11 times the 7. And then you're going to do the cosine of the angle, which is 110. I mean, there's a decent pattern there. Square root sine. The other two sides, right? The sum of them squared from the Pythagorean theorem concept. Then the minus 2. Same two sides multiplied, then the cosine of the angle. All right, make sure you can punch it out. And hopefully you got 14.9, right? Anybody agree, 14.9? So again, you got to make sure that you're punching things correctly to end up in that situation. All right, and that's just one of the values, right? We now have C. We still need to get, what, the two angles now. So honestly, at this point, and I'm going to put a little number 1 here. We did that first. Let's go ahead and get angle A. You want to use the law of sines? Most students like the law of sines better. That's what I would do. So I would do sine of angle A over its opposite side, 11, right? Equals the sine of angle C. That's the only one we know, right? So the sine of 110 divided by the value of C, which we just found, 14.9. Again, whenever you find the angle, what button are you using? Sine to negative 1, right? So on this one, you get the measure of angle A is... Anybody got it? 43.9 degrees. Let's you catch up. Sometimes it's not good to use your values that you've gotten to find other values, but you know what? In the situation with the angle, it's just such a time saver. Trust yourself on that. So what's left? The measure of angle B, and that's just what, 180 minus the 110 for angle C minus the 43.9 we just got, right? Angle B's got to be the 180 minus angle C minus angle A, because the three angles of a triangle is 180. And what does that leave? 121.2? No. 126.1? What in the world? Oh, yeah, it can't be 1, brother. Oh, I love it. I already used 110. What is the answer? 26.1. What in the world am I looking at? I have no idea. 26.1. Beautiful. All right. Great. So 180 minus 110 minus 43.9. So we solved the triangle, same thing as last night. You got to find all other sides, all other angles. And so this one, we started off with the law of cosines to get C. We were then able to use the law of sines. It's quicker, it's shorter, less probability of a calculator error. So the law of sines is more efficient. And when you can use it, you should. I mean, you could do the whole problem with law of cosines if you wanted, but it becomes a little bit more tedious. Okay, last situation. You're given a problem like this, you have to be thinking, look, I'm just going to tell you flat out. Let's suppose this problem was an odd. I see your paper and you have x equals 4, y equals 5.3, z equals 14, and then you've got the answers to it, and you have no picture. You know what common sense tells me? You copied it off the back of the book. Because how in the world are you doing it without a picture? Okay? Most of you, I mean, it's just not going to happen. Draw a picture, draw a picture, draw a picture, draw a picture, draw a picture. All right? You could do it without, but I'm just telling you, it's foolish. Whenever you have a triangle problem, draw a picture, start there, and then have a visual and go from there. All right? You probably could do it without, but it's foolish. All right, how are you going to draw it? However way you want. Put your X, Y, and Z wherever you want. You know, I'm looking at the numbers. A 4 and a 5.3 and a 14. So how about a 4, a 5.3, and a 14, right? So angle Z is across from the 14, angle X is across from the 4, and angle Y is across from the 5.3. Agreed? Okay. Let's all go for the same angle first. What do you guys want to go for? Angle X, Y, or Z? Z. The Z's have it. All right. So remember, you're going for angle Z, right? So here, I better do it this way for you. It's going to be Z squared equals X squared plus Y squared minus 2XY cosine Z. And so remember, this is what my next step would look like. I would right off the bat write cosine of -1 and put my parentheses. And then I'd have my top parentheses. What is Z? 14, so it's 14 squared, right? What comes next? Minus the X squared, because you're putting the X on the other side, right? We're moving the stuff on the right to the left. What's X? X is 4, so minus 4 squared. Minus 5.3 squared. Close that top parentheses, fraction bar. Bottom parentheses, -2 times the 4 times the 5.3. Make sure you don't use the 14 on the bottom. Close that parentheses. Close the whole parentheses. And you should be where you want to be. Okay, my numbers go. I'm going to make sure because I did that fast. Let's see. Blah, blah, blah. X, Y, X, Y, yeah, X, Y, yeah, sounds good. -2, AB, yeah. All right. So cosine of -1. Anybody got a nice answer? Anybody have a good answer for me? We don't have an answer? Anybody have an answer? Jeff? With parentheses. No, I think your calculators will be okay because now you have 3 parentheses. So I think you're okay without them there. I think your calculator will do it correctly. Anybody got an answer for me? Come on, speak. Huh? So what's the answer? Tell me the answer. I want to know the answer. No triangle exists. Anybody recall what I mentioned in the beginning, the geometric theorem, that any 2 sides of a triangle, the sum of them has to be bigger than the third? You could have saved yourself a whole lot of trouble if you knew geometry. All right, but that can happen. No such triangle exists. You can draw it, but it doesn't mean it exists, okay? All right. It can be drawn, but it doesn't mean it's true, and that is the case. All right, so be aware of that. That can come up with the law of cosines as well. No such triangle can exist, and just look out for it. Okay, last thought. How do you know when to use the law of sines or the law of cosines, right? How do you know when to use the law of sines or law of cosines? Always look to use the law of sines first. I mean, courses go through this ASA, SAS, SSS. Okay, great. Are you going to remember that a year from now? Most of you, you're not. But hopefully you can still remember the law of sines and law of cosines. Simply try the law of sines first. See if you have enough info for the law of sines. If you got enough info for the law of sines, use the law of sines. If you can't use the law of sines, then use the law of cosines. So one last thought here. Remember, if you just learn the first intonation, you should be able to do all the rest. Students usually don't have a problem solving for a side. Where do they get issues? In solving for the angle. So be careful. If you need to write more steps of the formula, then do that. Do what it takes to be able to get you to be efficient. All right, that's it. Homework, and then we'll pick up here on Monday.